This is our first example of solving a system of equations by substitution. Here are the two equations that we have. First decision we have to make is which of these four variables is the easiest one to get all by itself, to isolate. And always you want to choose the one that has no coefficient or a coefficient of 1. So you don't want to choose this because it is a 2 in front of it. You don't want to choose this because there's a 4 in front of it. Don't want to choose this because of the negative 2. This is the variable that will be easiest. So step number 1 is isolate a variable. I'm going to isolate that x by subtracting 2y from both sides. That is the end of step 1. Now I'm going to take this expression. I now know that x is the same as negative 2y plus 7. And I'm going to substitute this, negative 2y plus 7, in for this x. So I'm going to rewrite this equation. And now substitute. In place of that x, I'm going to take what x is equal to. X is equal to negative 2y plus 7. So x can be rewritten as negative 2y plus 7. Now it's really important that you then get everything else that's part of this equation. We have negative 2x plus 4y equals 10. That's the end of step 2. Now step 3 says solve this. Distribute 4y minus 14 plus 4y equals 10. Combine like terms. 8y. Add the 14 over there. 24. Divide by 8. Y equals 3. So that was the end of step 3. The last thing to do is to take this value of 3 and to substitute it into what I had from step 1. I'm going to put the 3 right there. Negative 2 times 3 plus 7 is negative 6 plus 7, which is just 1. And that is my answer for x. I now have my answer. I can write it x equals 1, y equals 3. Or I can write it 1, comma 3. This is my solution. If we had graphed these lines, that's the point of intersection. We can check our answer by plugging it in. 1 plus 6 equals 7. Negative 2 plus 12 equals 10, and we know we have the right answer.